Welcome back, and I'm doing a video on electricity here, and I'm going to talk about something which generally students have difficulty with when they are trying to solve a question on an electric circuit, right? And the 2 points or the two things that we're going to discuss is the potential drop across a resistor and current flowing in a branch of a parallel circuit. So I'm going to address these two things and try to explain to you with the help of this electric circuit how to find out the potential drop across a resistor, and then how to find current flowing in the branch of a parallel circuit. So for that I have taken this circuit, and we will be solving this question and trying to get an answer to both these things. Okay. So this is a circuit in which we have a battery of 2 volts. The internal resistance is 2.8 ohms. We have an ammeter in which current will be measured, and then we have these resistors 4 ohm and 3 and 2 ohm in parallel, right? If we want to find out potential drop across a resistor, first we will have to find out electric current flowing in this circuit, right? And let us begin by doing that. To find out the electric current in the circuit, I have to use the equation electric current I is equal to epsilon upon RT. Epsilon is the electromotive force, the EMF in the circuit, right? And RT is the total resistance in the circuit, right? Epsilon is known to us, it is 2 volts, the EMF of this battery, 2 volts. Total resistance I will have to find out, right? For doing that, what I'll do is I'll identify or name the various parts of the circuit, right? So let me name various parts of the circuit. Let us call this point, let me use a darker pen, right? Let me use, right? Let us call this as point A, point B, C, D, this is say E, and let us say this is F, and this point is G. Okay. Now I want to find out the total resistance of this circuit. So RCD, right? RCD, the resistance in the part CD is 4 ohms, so that is known. RDE, this is a parallel circuit, so I will use the formula for finding out resistance of parallel circuits. So that is 1 upon RDE is equal to 1 upon 3 plus 1 upon 2, and RDE therefore will turn out to be to save time I'll directly give you the value. It will turn out to be 1.2 ohms, right? So RDE is found out. The resistance of this part of the circuit is 1.2 ohms. Apart from that, we have RGA, which is directly given to us, internal resistance of the circuit, 2.8 ohms. So I have got 3 resistors in the circuit: RCD 4 ohms, RDE 1.2 ohms, and RGA 2.8 ohms. Therefore the total resistance of the circuit will be 4 plus 1.2 plus 2.8, and that will be 8 ohms. Now I can find out the electric current flowing in the circuit. I is equal to epsilon, which is 2 volts upon 8, 2 upon 8, that will give me 1 upon 4 ampere, that is 0.25 ampere. So I have found out the electric current flowing in the circuit, right? Let me write down over here, I is equal to 0.25 ampere. Okay. So how does this current flow in the circuit? Since this is the positive terminal of the circuit, electric current will start from here, 0.25 ampere will start from here, it goes over here, it passes through the ammeter, and then it reaches point C, it reaches here. When it encounters resistance, right, some part of the energy, so it will need some energy to flow through this, right? So let us begin that discussion. Now we're going to address this question. We're going to try to find out potential drop across a resistor, right? So let us find out. Let us say we want to find out the potential drop across resistor 4 ohms. That means I have to find out VCD, right? Potential drop is nothing but potential difference, so we will use the symbol V for that. I want to find out VCD. To find out VCD, we need to understand the meaning of epsilon, right? So let us say epsilon. Epsilon is 2 volts. What does this mean? Epsilon 2 volts is the total energy available to make the current flow in the circuit. I think I will write it down, right? Epsilon is equal to 2 volts is the total energy available to make the current flow through the circuit. So this is the total energy available. Now 0.25 ampere current starts from A, reaches B, reaches C, and when it reaches here, right, it encounters resistance of 4 ohm. So out of these 2 volts, a part of the energy is given to the electron so that they are able to overcome the resistance and move further. Similarly, when they reach D, some part of 2 volt will be again given over here so that it is able to overcome the resistance offered by this DE part of the circuit, and it is able to move ahead. So this particular part of the energy, right, out of 2 volts, which is used over here, is known as the potential drop across this resistor. So VCD is nothing but that part of 2 volts which is used over here to make the current flow through 4 ohm resistor, and it is given by current flowing into the resistor multiplied by resistance of the resistor. I have written this in, basically this is nothing but current into resistance, right, because V is IR, right. If you look at the general formula for potential difference, it is I into R. But the question is which current we have to take and which resistance we have to take. Therefore I have written this in words. For calculating the potential drop across VCD, I have to multiply the current flowing into this resistor, the current which gets into this resistor, and the resistance, right. Therefore VCD will be, the current flowing into this resistor is 1 upon 4, 0.25, right, 1 upon multiplied, the resistor is 4, resistance is 4, so 1 upon 4 into 4, that will give me 1 volt. That means out of this 2 volt, 1 volt has been used to make the current flow through the 4 ohm resistance, right. That is the potential drop across this resistance. Similarly, let us calculate VDE.